Hello everyone. Today in the chapter Operations on Rational Numbers, we will study decimal form of rational numbers.
Hello everyone. Today in the fifth chapter Operations on Rational Number, we will study decimal form of rational numbers. Means converting the rational numbers into the decimal form. So for this, what we have to do? We have to do the division. So to understand converting decimal form of rational number, we will take example 7 upon 4. So that means you have to divide this 7 by 4. Now you can understand that this 7 cannot be completely divided by 4 because 4 is not a factor of 7 or 7 is not present in the table of 4. Therefore, definitely the answer, this quotient is going to come somewhat decimal fraction. So what we will do? We will take here 0.1230 after the point. So no matter if you take any number of 0 at the end of this decimal fraction part, that means at the end of decimal fraction part, if you take any number of 0, there is no change in the given number. See, 7.00 means it is 7 only. So we will take it here. Now 4 ones are, it will be 4. So here 7 minus 4, it will be 3. Then you are taking the digit after decimal. So take it here, this 0. And as you are taking a number after decimal, so give decimal point here. Now there is a 30. So 4 sevens is 28. So there will remain 2. Take this next 0 here. So 4 fives is 20. So 0 0. So remaining last 0 will take here and also give here. So therefore your 7 upon 4 will be equal to 1.750. That is also equal to 1.75. So this is your converting rational number into the decimal form by this way of division. One more example is given here. Let us see that. Now it is 2 and 1/5. So it is a mixed fraction. Convert this mixed fraction into the common fraction. So how is that? You see, multiply 5 to 2. So that will be 5 2s are 10 and add 10 plus 1, so that will be 11 upon 5. Now you will divide 11 by 5. So since you know that 11 cannot be completely divided by 5, so take 0.00. Now here 5 2s are you will take 5 2s are 10 minus, so 1 will be here. Take this 0, so you are crossing decimal, so give decimal and take 0 here. So 5 2s are 10, 0 0, so this 0 and 0 here. That means 2 and 1/5 is equal to 11 upon 5, which is equal to decimal fraction 2.20, which is equal to 2.2. So this is your decimal form of the given rational number. And this type of division where you get the remainder in the form of zeros, that means if your remainder is 0, that type of decimal fraction is called as a terminating, or you can say terminated decimal form. Terminated decimal form. So this 2.2 is a terminated decimal form of 2 and 1/5, that is 11 upon 5. So this 1.75 is a terminated decimal form of 7 upon 4. So this type of decimal fraction where you get a remainder 0, the complete division is possible. So that type of division or the decimal form obtained is called as a terminated decimal form. So you can see here that terminated means completely terminated, completely converted. That means no part is remained behind. Or when we are doing the division, means there is a complete division possible here. That is why this decimal form is called as a terminated decimal form. This rational number is completely terminated in the form of decimal. That is why it is called as a terminated decimal form. So now here we will take some more example, 5 upon 3. So you have to convert this rational number into the decimal form. So what we will do? We will do the division. So 5 will be divided by 3. So take 0.00. Now 3 ones are 3. So 2 will be here. You have to take this 0 here, but you are crossing the decimal. So take decimal and take 0 here. Now 3 6 is 18. So you will have here 2. So take this 0 down. So it will be 20 again. Again 3 6 will be 18. Again 2. If you take one more 0 here, it will be again 20. Again 6. Again 20 minus 18. It will be 2. Again 0 means 6 will be repeated here. 6 is repeated here. So you can say that 5 upon 3 is equal to 1.666 dot 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 dot. If you continue doing this division, it will never end. It will never end. That means that division will be continuously going on, and in your question there will be added 666 in each every step of the division. That is why it is repeating. 6 is repeating here. So we say that one point we will take only one 6 and give dot upon it. We will give dot upon it, which we understand that this 6 is repeating again. Means it is recurring. It is recurring. Repeating means recurring, and this form of decimal is called as a recurring decimal form, where there is a repetition in the quotient. A single digit is repeating here, so we are saying that its decimal form is 1.6 and just give a round dot upon that number which indicate that 6 is repeated here. So it is a recurring decimal form. So we'll see this example now. So 2 is divided by 11. So take 2 point some zeros here. Now you will see that this 2 cannot be divided by 11. So what will take? Take 0. 11 zeros are, it will be 0. So 2 minus 0 will be 2. Take this 0 down. As you are crossing the decimal point, take here decimal point and take this 0 down. Now 11 ones are will be 11. Then 20 minus 11 it will be 9. Take this 0 down. So here 11 8s will be 88 minus, so now 90 minus 88 it will be again 2. Take this 0 down, you will get here 20. So again 11 ones are 11, you will get here 9. So we will take one more 0 here. So again here will be 0. Again 11 8s are 18. Again you will get 2. So if you take one more 0, it will be again here. So you can see here 20 90. 20 90. Again it will be 20, again 90. 20 90 20 90 is repeating. Means definitely if you continue to divide it at the long steps, you will be getting 1818 repetitively. Again here 18181818 continuously you will be getting. This division will never finish. So that is why it is repeated. What it is repeating? It is repeating a group of digit 181818. So there is not single digit repeated, but a group of digit is repeated. So we can say that this 2 upon 11 will be equal to 0.181818 dot 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 dot. Means a group will be repeated. So since there is a group repeating, it is a recurring decimal form because repetition is there, and that is why you can say 0.18 you will give a dash upon the 2 digit. That means this group of the digit is repeating again and again. So when there is a group of the digit repeated, you have to give the bar or a dash on that 2 or 3 whatever the digits are there in a group of that number, and you have to give a single dot if there is a single digit repeating. So this is also a recurring decimal form. So you have learned that when you divide a rational number to get a decimal form, either it is decimal form is coming in a terminated decimal form or it is coming in a recurring decimal form. So in this way you can convert given rational number into the decimal form. Definitely will get answer in a terminated decimal form or recurring decimal form. In the recurring decimal form, you should have to know that you have to give a dot when a single digit is repeated, and you have to take the line when there are a group of digits repeated. We will learn simplifying the expression. Means when there are number of operations in given one equation. So you can see here is multiplication, division and addition of this 4 numbers. Here also in this example you will see there are multiple operations. Division, addition, subtraction, and again there is a addition. So when there is a multiple operations, at the same time you have to solve this example by some rule. So what is that rule? Now you see the rule is B O D M A and S. So it is a BOD, board, MAS, mass, board mass. So what this board mass rule means? This is the board mass rule. So what this board mass rule means? So B for bracket means if in the equation there is given a bracket. So first you have to solve whatever the operations are there inside the bracket. So first you have to solve the bracket and then you go for the next operations. So first you have to solve the bracket. Then off. Off means off wala multiplication. Off multiplication means what? Half of 20. That means half into bracket 20. So half, whenever there is a number out of the bracket which is multiplying to the bracket, that condition is called as a off multiplication. Then D, you can understand it is a division, M it is a multiplication, A it is a addition. So this is division, M multiplication, A addition, and S for subtraction. Means if there is a multiple operations, what you have to do? You have to do first division, then multiplication, then next addition and subtraction. By following this board mass rule, we will solve the given examples now. Now this example, we will write it again. 40 into 10 divided by 5 plus 70. So we will write here rule, board mass. So we will understand what to do first and what to do next. So here board mass, bracket is not there, off is not there, division is there. So this is division here. So first you will do division. So if you do the division, keep this all the numbers as it is, keep this sign also as it is. Now divide this 10 divided by 5. You will get 2. Finished, plus 70. Now what is the next? Multiplication. So first you do the multiplication now. So if you do the multiplication, 40 2s will be 80 and plus 70. So there is only one operation, add it, you will get the answer 97. In this way you have to simplify the given expression by using board mass rule. Another example here, 80 divided by into bracket 15 plus 8 minus 3 plus 5. Now see board mass rule, B, bracket is there. So first you will solve the bracket. So first you have to solve this bracket. Remaining everything you write as it is. 80 divided by into the bracket. Now in the bracket there are two operations, addition and subtraction. So which to do first? Addition, subtraction. So first we will do the addition. So addition here, 15 plus 8 will be 23 minus 3 plus 5. So 80 divided by, again in the bracket. Now this bracket there is only one operation. That is 20 minus 3. So that will be 20. Open the bracket and your bracket will be now open. After open there are two operations again, division and addition. So what we will do first? Division. So first you do the division. So 80 divided by 20, it will be 4 plus 5. This 5 is remain. So your answer will be equal to 9. So in this way, you can simplify the given expressions by using board mass rule. So here another example is given. So you can see there is a multiplication, and in the bracket subtraction, addition, into the bracket again division, multiplication, and again bracket close. So you can see there are 3 brackets here. So here this is the biggest curly bracket. This curly bracket is multiplied by 2. But now inside this curly bracket again there is a 25 which is multiplying to this operation. And again in this square bracket again there are 2 small brackets which are here adding each other. So what we have to do first? So now which is the bracket interior inside? We have to solve them first. So you can see this is the first bracket, again this is second, and these are the 2 here inside. So first we will solve these 2 brackets which are in the inside. These 2 brackets we will solve. Remaining everything we will write as it is. So 2 into curly bracket into 25 multiplied by square bracket. Now 113 minus 9, it will be 104. So bracket will open. Plus into the bracket, there are two operations, so bracket will not open. You will now see there is a division and multiplication. What you will do first according to the Borman's rule? Division. So 4 divided by 2, it will be 2 multiplied by 13, again square bracket and closed by curly bracket. Now here 2 into 25 into 104. Now this bracket we have to solve first. Plus 2 into 13 means 13 2 is 26. This bracket will go. Now again we will solve this bracket, the bracket which is in the inside of the given equation. So we will open slow by slow, one by one for each bracket. Now this bracket, there is only addition, so add this 2. So 104 plus 26, it will be 130. So this bracket is gone now. Now there is only one bracket, this. So there is only operation multiplication, so multiply. So 2 into, the bracket will open after multiplication. So here 0, you take 0, 25 3 is 75, so 7 carry on, 25 plus 25 on the 25 and plus 7, it will be 32. So it will be 3250, which is again multiplied by 2. So 0, 2 zeros are 0, 10 2 5 are 10, 1 carry on, 2 2s are 4 plus 1 5 and 2 3s is 6. So your answer will be 6500. So in this way you have to solve this given expression by means simplifying the given expression by using the Borman's rule. So while solving such a kind of example, we have to find and we have to solve the brackets which are in the inside, and step by step we will get our final answer by using the Borman's rule. So now here is one more example. 3 upon 4 minus 5 upon 7 multiplied by 1 upon 3. So we will solve this now. Now again you have to use the Borman's rule. So you see this fraction is subtracted by this fraction and multiplied by 1 upon 3. So there is a subtraction and multiplication. So what you will do first? Multiplication. So you have to do the multiplication. So here it will be equal to 3 upon 4. Multiplication of these two. So this is minus 5 upon 7 multiplied by 1 upon 3. So you know the multiplication of fraction, numerator multiplied by numerator and denominator multiplied by denominator. So minus 5 into 1, it will be minus 5, and 7 into 3, it will be 21. Now you will see here, there is only a subtraction. So it is a subtraction of fraction. And you know, when there is a subtraction of a fraction, what is essential? Their denominators should be equal or they should be same. But they are not same here. It is 4, it is 21. So how will you make same? You know that you have to do the multiplication, cross multiplication. 21 you have to multiply to the 3 and 4, and this 4 you have to multiply to the 5 and 21. So 3 into 21 and 4 into 21 minus 5 into 4 and 21 into 4. So we will get 21 3s will be 63 and it will be 84 minus 20 and again 84. Now you see, you got the denominators same. So as you get the denominator same, take the common denominator, that is 84. Not 84 minus 84. You have to take it common and you have to subtract the numerator. So 63 minus 20. So that will be equal to 43 upon 84. In this way, you have simplified the given equation by using the Borman's rule. If you don't follow the Borman's rule, what do you think? You will get the same answer? Right? And of course you will find that if you do not follow the Borman's rule, your answer is going to get wrong. So while solving, while simplifying this kind of equation where there is a multiple operations, it is very essential to follow Borman's rule.